Picture this. You're standing on Earth, looking up at the stars, dreaming of touching space. Right now, that dream costs you either a lifetime of astronaut training or $1 billion bank account. But what if I told you there's a concept so revolutionary it could make space travel as routine as taking an elevator to the top floor of a skyscraper? Welcome to the world of space elevators, where science fiction might just become humanity's greatest achievement. Let me blow your mind with some numbers. Currently, launching just 1 kilogram into space costs around $20,000. That means sending an average person would cost over $1 million. And your car? Try 40 million. These astronomical costs aren't just numbers on a spreadsheet, they're the chains keeping humanity bound to Earth. But a space elevator could shatter those chains, reducing costs by 100 times to just $200 per kilogram. Here's where it gets fascinating. Unlike rockets that burn massive amounts of fuel fighting gravity, a space elevator works like nature's own cosmic hack. Think of a child spinning a toy on a rope. As you climb along that rope, you naturally start moving faster and faster. The space elevator uses Earth's rotation to give you that sideways speed for free. You only need energy to go up. The planet literally flings you into orbit. But building this marvel wouldn't be like constructing any ordinary structure. We're talking about the most ambitious engineering project in human history, a tower stretching 36,000 kilometers into space. That's nearly 3 times the diameter of Earth itself. The basic design sounds deceptively simple. A super strong cable anchored to Earth's surface, extending into space where a counterweight holds it taut like a cosmic fishing line. The climber, essentially a space-age elevator car, would carry passengers and cargo up this incredible tether. At the top, a space station could serve as humanity's first true spaceport, launching missions to Mars, the asteroids, and beyond. Imagine checking into a hotel at the edge of space, looking down at Earth while planning your next adventure to Jupiter's moons. But here's where reality crashes the party. The biggest challenge isn't the concept, it's the materials. We need something lighter than air, yet stronger than anything we've ever created. Current candidates like graphene and diamond nanothreads show promise, but even these wonder materials might not be powerful enough. The tether must survive not just its own enormous weight, but also atmospheric corrosion, radiation bombardment, and impacts from space debris traveling at bullet speeds. Then there's the power problem. Climbing 36,000 kilometers takes several days and enormous energy. Do we mount nuclear reactors on elevator cars? Beam power from Earth using super-powered lasers? These aren't just engineering challenges, they are technological leaps that make landing on the moon look simple. The risks are equally staggering. If the tether breaks near the bottom, the entire structure would rocket into space like a released rubber band. Break it near the top and it wraps around Earth like a devastating whip, creating a debris field that could cripple space exploration for generations. We literally get one shot to build this right. Some experts propose starting smaller, building humanity's first space elevator on the moon. With weaker gravity, existing materials like Kevlar might actually work. It's like learning to walk before attempting a marathon, giving us the experience needed for Earth's ultimate elevator. Despite these mind-bending challenges, the payoff could reshape civilization itself. A $20 billion elevator would pay for itself after launching just 1,000 tons of cargo, roughly equivalent to 2 international space stations. But the real value isn't measured in dollars, it's measured in dreams realized. Imagine asteroid mining operations supplying Earth with unlimited rare metals. Picture manufacturing in zero gravity, creating materials impossible to produce on our planet. Envision humanity spreading across the solar system, with Earth's space elevator as the starting point for our cosmic journey. Maybe we'll never build a space elevator. Maybe the material science will prove impossible or the economics won't work out. But in reaching for this incredible goal, we'll push the boundaries of human knowledge and capability. We'll develop new technologies, inspire new generations of scientists and engineers, and prove once again that humanity's greatest strength is our refusal to accept limitations. The space elevator represents more than just a transportation system. It's a symbol of human ambition, a testament to our species' unrelenting drive to explore, to grow, and to reach beyond the horizon. Whether it remains science fiction or becomes the foundation of our spacefaring future, the space elevator reminds us that sometimes the most important journey isn't reaching the destination, but daring to dream of it in the first place. But if scaling a 36,000 km tether into the stars got you thinking big, you won't want to miss the ultimate origin story. In our previous video, we dive into how the entire universe exploded into existence from a point smaller than an atom. Discover the cosmic spark that forged galaxies, stars, and even us. Tap the on-screen link now or check the description below to travel back to the very first moment of everything and fuel your next great sci-fi adventure.